Hello and welcome. In this video, we are going to talk about how to use the quadratic formula to solve a quadratic equation and how to use the discriminant to identify the number and type of solutions to a quadratic function. Let's go ahead and get started. So we've been talking about a variety of different ways to solve quadratic functions, and we started Chapter 3 by talking about what a solution to a quadratic function is and relating that back to the graph. So we have said that if we find two solutions, what we're saying those solutions are they're the x-intercepts. They're where our graph crosses the x-axis. So this here would have two x-intercepts, which would mean that it has two real solutions. Similarly, occasionally we'll solve and we'll end up with only one solution, and that one solution crosses the x-axis or stops the vertexes on the x-axis. And that would mean that we have one real solution. And what we have also said is that we sometimes have quadratic functions that don't have any x-intercepts, but now that we have imaginary numbers, we can solve to find two imaginary solutions for a graph like this. So we're going to tie those things together with the quadratic formula. The quadratic formula comes from completing the square, so taking the idea of starting with our standard form and actually performing complete the square. So factoring out an a, taking half of b and squaring it and adding that. And then after we do all those steps to complete the square, actually solving for x. That's where the quadratic formula comes from. It allows us, or it is derived from completing the square on standard form. The quadratic formula will work anytime we have a quadratic equation that is in standard form, because in order to use the quadratic formula, we need to be able to identify what a and b and c are so that we can plug them into this formula and simplify. So again, that's only going to work for us if we have a function or an equation that is in standard form. The quadratic formula is great because it enables us to solve problems that maybe don't factor. It enables us to solve problems that would be challenging to complete the square on and that we don't want to graph. And it's nice because it really just is a formula that we have to memorize so that we can plug in those values and simplify. Now, all those things being said, the quadratic formula is a formula, which means you can't use it if you don't know it unless you want to derive it by completing the square. So you have to have it memorized, and there's lots of ways to memorize the quadratic formula. You can learn it to the tune of a song, you can learn it by writing it down repeatedly, but it is something that you have to know. And one specific part of the quadratic formula, actually the part that is inside the square root, this b squared minus 4ac, it has a special name. It's called the discriminant. And it tells us how many and what type of solutions there are to a quadratic equation. And that makes sense because if you think about what we're doing in this quadratic formula, we're taking the opposite of b and then we're adding and subtracting the square root of b squared minus 4ac. So if we were taking the square root of, let's say 4, then what we're doing is we're going to be adding and subtracting 2, which means we're going to have two real solutions. So if the number inside the square root, if that discriminant value is positive, then we're going to have two real solutions. If the number inside the square root is negative, so if let's say instead of 4, it was negative 4, if we take the square root of negative 4, we get plus or minus 2i. So this is going to have two solutions as well, but it's going to have two imaginary solutions. And then what happens if we take the square root and inside we get 0? Well, the square root of 0 is 0. It doesn't matter if we add 0 or subtract 0, the square root is going to be 0. So that means we're only going to have one real solution. So it's important not just to identify how many solutions there are, but what types of solutions there are based on what's happening inside that radical. Let's look at some examples of using the discriminant. So here we have some examples, and I'm going to go ahead and write what that discriminant is just on the top up here. That discriminant is the inside part of the square root, which is b squared minus 4ac. As a reminder, when we're doing this, we need our quadratic equation to be in standard form. So ax squared plus bx plus c equals 0. And in this case, all three of these problems are already in standard form. So we can identify on number 1, a is 1, b is -6, and c is 10. So b squared in this case would be negative 6 squared minus 4 times a times c. So 4 times 1 times 10. Negative 6 squared is 36. 4 times 1 times 10 is 40. So the value of the discriminant is going to be negative 4. And if the discriminant is negative, that means we're going to take the square root of negative 4, which is going to give us plus or minus 2i. So we have 2 imaginary solutions. And we haven't found what those solutions are. We're going to talk about how to find those solutions with the quadratic formula later in this video. We just are being able to identify this particular quadratic equation that we started with. When you solve it, there will be 2 imaginary solutions. So if we look at number 2, a is 1, b is negative 6, and c is 9. B squared is going to be 6 squared minus 4 times 1 times 9. That's going to be 36 minus 36. So the discriminant is 0. And what does a discriminant of 0 mean? It means that we have one real solution. In fact, that means the vertex of this quadratic is touching the x-axis. So there's 2 parts to the answers to these types of questions. What is the value of the discriminant, and how many solutions and of what type are they? So I'm going to encourage you to pause the video and work through number 3 on your own, and then unpause the video and see how you did. All right, a is 1, b is negative 6, c is 8. So negative 6 squared minus 4 times 1 times 8. 36 minus 32. This quadratic is going to have a discriminant of positive 4, which means there will be 2 real solutions. So now that we've worked through dealing with the discriminant, the inside of the square root, let's go ahead and look at how to solve quadratics using the quadratic formula. All right, since we're going to be using the quadratic formula, I want to go ahead and write it up on this page. So I encourage you to pause the video and see if you can write the quadratic formula from memory down on your paper. So here it is. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, in order to use the quadratic formula, we have to have our equation in standard form equal to 0. So for number 4, the very first thing I'm going to need to do is subtract 5 so that this equals 0. Then I can identify a, b, and c, and then I can plug them into the quadratic formula. So the opposite of b is negative 3, plus or minus the square root of 3 squared, minus 4 times a is 1 and c is negative 5. All over 2 times 1. Now, a couple things I want to point out here, just notationally, make sure that your square root covers everything it's supposed to cover, that it doesn't just stop. Also, make sure the fraction line for your denominator covers everything it's supposed to cover here. Now, from here, you're going to show as many steps as you need to show to get you correctly to a simplified final answer. What I like to do is I like to deal with the discriminant sort of off to the side. So I'm going to move down here. That's going to give me 9 minus 4 times 1 times negative 5. So the negative 4 and the negative 5 are going to combine to be 20. So my discriminant is 29. So I'm going to have the square root of 29. And this is all going to be over 2. Now, if 29 simplifies, if the square root of 29 simplifies, I need to make sure that I do that, but 29 is a prime number. So I'm going to put set notation around my final answer, and I'm done. Number 5. First thing I want to do is make sure everything is on the same side so that I have this in standard form equal to 0. I can see what my a and b and c are now. So x equals the opposite of b is negative 4, plus or minus the square root of 4 squared minus 4 times 3 times negative 10, all over 2 times 3. And I really want to see this step where you're writing everything out plugged in before you do any simplification. Because then if you make a mistake, if you multiply wrong, if you subtract wrong, I know where your mistake was because you set it up correctly. So again, I'm going to deal with my discriminant off to the side or down below. So I'm going to come down here. 4 squared is 16. Negative 4 times 3 is negative 12 times negative 10 is going to end up giving me plus 120. So 16 plus 120, this discriminant is going to be 136. And then I'm going to need to simplify that radical. Well, 136 is 2 times 68. 68 is 2 times 34. 34 is 2 times 17. So that radical can simplify. So x equals -4 plus or minus. That radical is going to simplify to be 2 times the square root of 34. And this is all over +6. Now we're done simplifying our radical, but what we can simplify, since we factored a 2 out, is all of these numbers are even. So all of those numbers we can divide by 2. Don't divide 34 by 2. You already simplified your radical when we did that work in blue. So this is going to be x equals, well, if I divide 4 by 2, I get 2. So -2 plus or minus. If I divide this 2 by 2, it's going to go away. So -2 plus or minus the square root of 34. And if I divide 6 by 2, I get 3. All right, let's do one more together, and then I'll have you practice some on your own. So first step, get everything on the same side. So if I subtract 12x on both sides, I'm going to get -20x. And if I add 4 on both sides, I'm going to get +4. Now I'm going to identify A and B and C, and I'm going to plug them in. So the opposite of -20 is 20, plus or minus the square root of -20 squared minus 4 times 25 times 4, all over 2 times 25. So x equals 20 plus or minus, well, what's happening inside this square root? I'm getting 400 minus 4 times 25 times 4. Well, that's 400 also. So plus or minus the square root of 0 over 50. So this is just going to give me 20 over 50, or 2/5. So in this case, I only have one solution, and that one solution is 2/5. So let's go ahead and look at some more problems, and I'm going to encourage you, once I get them up on the screen, to try them on your own. All right, here we go. 3 more problems for you to practice. Go ahead and pause the video, get everything on the same side so you can identify your A, B, and C, and then solve using the quadratic formula. Then unpause the video and see how you did. All right, so hopefully you've had time to work through these. What I've done here is just made sure everything is equal to 0, so I've gotten everything on the same side. And before I jump into number 7, the very first thing that I noticed is that all of these numbers are divisible by 4. So if I divide everything by 4, I'm going to still be able to use the quadratic formula, but these numbers are going to be so much smaller. And I actually notice, even though we're learning the quadratic formula, that this particular function in number 7, now that I've divided that out, it looks like it factors. It actually looks like it factors to be the perfect square, x plus 2 quantity squared, which means I'm going to wager my only solution here is going to be x equals -2. But since we're learning the quadratic formula, let's go ahead and work through it this way. X equals the opposite of b is -4, plus or minus the square root of 4 squared minus 4 times 1 times 4, all over 2 times 1. Inside this radical here, we're going to end up with 16 minus 16. So -4 plus or minus the square root of 0 over 2, which is just going to be -4 over 2, which is -2. On number 8, x is going to equal the opposite of b is -4, plus or minus the square root of 4 squared minus 4 times -1 times -13. It's a lot of negatives in there. All over 2 times -1. So x equals -4 plus or minus. Inside this radical, I'm getting 16 minus 13 times 4, 52, which is going to be 36, -36. And we know how to take the square root of -36. The square root of -36 is plus or minus 6i divided by -2. And then we can simplify this. If I divide -4 by -2, I get +2. If I divide 6 by -2, I get -3, and I have this plus minus, so that's covering both the positive and negative version. So here's my final answer. And then the last one, x equals -2 plus or minus the square root of 2 squared minus 4 times 5 times 1 all over 2 times 5. So x equals -2 plus or minus. I'm going to go ahead and simplify this radical off to the side. So 4 minus 20, that's going to give me -16. And we know that we can square root -16 to get plus or minus 4i. So -2 plus or minus 4i over 10. And again, we can simplify this to be -1 plus or minus 2i over 5. So that's using the quadratic formula. If something doesn't evenly square root, like maybe we had the square root of -26, we would have plus or minus I root 26, and we could have some other numbers around that. So if it doesn't simplify, that's okay. Just simplify as much as you can, and always make sure to take a negative out of a square root by using I. Okay, the very last thing we're going to do in this video is we're going to look at a word problem, because I don't think we could ever get enough practice on those. Okay, so the function h equals -16t squared plus h naught. We talked about this previously. This function is used to model the height of an object being dropped. So if I just picked up a ball and I just let go, and we talked about this and did some word problems with this in our very first section. Now, if instead of just dropping the object, I threw the object or I launched it, then there's going to be a velocity component that's playing a role here. So you don't need to have these two functions memorized for this class. We will give you the functions if you need them, but you do need to know how to use them. So this function is saying -16t squared plus v naught times t. V naught is just the initial velocity, plus h naught, which is the initial height. So if we use this model, which is a real world model of how the path of an object being thrown or launched would follow. So then we're going to apply that to question 10 here. You are playing an epic game of dodgeball with your friend Ben Stiller. You throw the ball at Ben in an attempt to knock him out of the game. The ball leaves your fingertips at a height of 4 feet. So we were just given our initial height, and goes hurling through the air at an initial velocity. So we were just given our initial velocity of 30 feet per second. Unfortunately for you, Ben catches the ball at a height of 3 feet. So I'm not sure exactly where this is going to come in, but at some time the height is 3 feet, knocking you out of the game. For those few short seconds the ball was in the air, you thought you were going to be the dodgeball champion. How long does it take before your dreams were crushed? So the first thing that we're going to do is we're going to write the model using what they gave us here. So our model is going to be h of t is equal to -16t squared plus the initial velocity, which we were told is 30 feet per second. So 30 times t plus the initial height, which we were told is 4. So here's our model. The second thing we're going to do is we're going to see what we're trying to solve here. So how long was it before the ball was caught? Well, the ball was caught at a height of 3 feet. So what I really want to know is, when is my function equal to 3 feet? Because that's asking me for the height. So now I'm just going to solve this quadratic, and we can solve this quadratic using any of the methods that we have learned. So we have learned that we can solve by graphing. I don't think any of us are really looking forward to trying to graph something like this. We could solve it using square roots. In this particular problem, we're going to be able to see it in standard form, so that's not going to work. We could solve by factoring if it factors. We could solve by completing the square, or we could solve using the quadratic formula. This particular problem, I think with this big of numbers, I'm not going to be able to tell right away if it factors. I'm going to solve using the quadratic formula. So I'm going to move my 3 to the other side. So -16t squared plus 30t 4 minus 3 is going to give me plus 1. And now I'm going to solve using the quadratic formula. Instead of x equals, I'm going to have t equals. The opposite of b is negative 30 plus or minus the square root of 30 squared minus 4 times negative 16 times 1 all over 2 times 1. And then I'm going to go ahead and simplify inside the square root. 30 squared is going to give me 900. Negative 4 and negative 6 times negative 16 times positive 1 is going to give me 64. So negative 30 plus or minus the square root of 964, all divided by 2. I'm going to give myself a little bit more room here. I'm going to do the upside down birthday cake with 964. So that's going to give me t equals negative 30 plus or minus 2 times the square root of 241 over 2. Now this question is asking me about time, so it's not going to make sense for me to talk about a negative number. And if I do negative 30 minus whatever that number is, it's going to be a negative number. So in terms of me answering this question, I'm only going to look at the positive number. So I'm going to just say, since time is positive, what we're really saying is negative 30 plus 2 times the square root of 241. That's going to be some sort of positive number all over 2. So to answer the question, which we would do in a complete sentence, we're going to say my dreams would be crushed at that many seconds. And there we have it. So key ideas in this section: using the discriminant to determine how many and what type of solutions we have, using the quadratic formula to solve a quadratics, and extending that idea to solving quadratic word problems. So go ahead and write down any questions you have. I look forward to supporting you on this. Thanks for listening.